Alright, we are going to review how to factor polynomials of the type ax squared plus bx plus c. Now this video assumes that you are all over type 3 factoring. Type 3 factoring is the same thing except the a is always 1. So it's x squared plus bx plus c. There's another video that explains how to do this. Basically we use mental math by figuring out, well, what factors of c add up or subtract to the b term, depending on what the signs are and that sort of thing. Now, when we have a non-1 coefficient and also non-zero, right, so it's not 0, it's not 1, but it's some other real number, it's a little more complicated. And there are several methods to do this. You can use mental math. You can just figure out different combinations of factors and find it. There's the box method, there's diamond method, there's all kinds of different ways of doing it. I am going to describe the grouping method. So the other thing that is an assumption here is that you understand type 4 factoring, which is using grouping. So if you're not up on type 3 and type 4 factoring, you might have a little trouble here, but follow along anyway, and if you're not quite ready for it, go back, master type 3, master type 4, and then come back to type 5 factoring, you'll find it's not so bad. But let's look at an example of what I mean by ax squared plus bx plus c. So suppose I want to factor 2x squared minus 7x plus 3. So let's see, let me identify a. A of the ax squared, a is 2. The b of bx is that negative 7. And the c is 3. So my first thing I want to do here is I want to multiply a times c. Well, what's a? A is the coefficient of the x squared, so it's 2. And what is c? That's my constant term, that's 3. So to multiply ac, I say multiply 2 times 3, and I get 6. So, whoops, 2 times 3 is 6. Then what do I do? Well, kind of similar to what we did with type 3 factoring, except instead of wondering about just c by itself, I want to multiply that 8 times c, that's 6, and I want to know what factors of 6 add up to that 7. And, the negative will become significant, but let's first think about if I just want factors of 6 that add up to 7. And we do the same process we did with the type 3 factoring, is I'm going to list the factors of 6. I've got 1 and 6. And 2 and 3. Well, which ones of those add up to 7? Well, it's certainly not 2 and 3 because that only adds up to 5, but 6 and 1 is 7. Those are the ones I'm interested in. So what do I do with that? What I'm going to do is I'm going to take this middle term and I'm just going to break it apart. I'm going to split it up. So I still want it to, add up to 7x, but I'm going to use these factors. I'm going to use the 6 and the negative 1, or the 6 and the 1, and if I have a negative 7x, I just kind of break it apart. Negative 6x minus x, doesn't that equal negative 7x? Have I really done anything to change the value of this expression here? I haven't. I've just split them up. So now I have 4 terms. And that's where type 4 factoring comes in, which is grouping, which says if I have 4 terms, I can use my grouping method, which basically says kind of group these into 2 different pieces and factor each one separately, and then come back and factor them together. And let's see what I mean by that. So I want to look at this, and I'm going to just split it into 2 pieces. So I take my 2x squared minus 6x, that's my first piece, and I'm going to add to that the second piece, which is that negative x plus 3. So you do want to be careful. If this sign, or if this term here is negative, he gets kind of closed up in that parenthesis, but you are adding these 2 things together. And again, this is equivalent to this, which is equivalent to that. We really haven't done anything yet but rewrite the expression. So now what we're going to do is we factor this group, and then we factor that group. Well, if I factor this group, I'm going to use type 1 factoring. Remember what type 1 factoring is. It says pull out a common monomial from this, the greatest common monomial, which, by the way, you always start with type 1 factoring. There is no greatest common monomial here, but if there had been, you always factor that first and then apply this method to the factored expression that's left. Anyway, I'm down here. What is my greatest common factor here? Well, the greatest common factor between 2 and 6 is 2, and the greatest common factor between x squared and x is x. So 2x is my common factor. What's left when I kind of pull that out? I divide 2x squared by 2x, I'm left with x. If I divide that 6x by 2x, I'm left with 3. And again, I do my little mini check. distribute back. That's 2x squared, and that's minus 6x. Okay, I did that correctly. Now with this one, kind of interesting here. I can't really factor it, but I know where I'm heading. I know that I want these to be the same. If I factor out a -1, and again, kind of using that type 1, I'm going to factor out -1. So there's really a -1 here. I don't have to put the 1 in, so I didn't. But what happens here, it kind of flips the signs of both of them. So I get my x minus 3. And again, check it. That's -x. Negative 3 is positive 3. Because the goal here is I want a common polynomial, which I got. So I'm going to factor out this common polynomial of x minus 3. That's here. And then what's left? If I pull that out, I divide this by x minus 3, I'm left with 2x. If I divide this side by x minus 3, I'm left with that 1, and that's where the minus sign is. So x minus 3 times 2x minus 1, those are my factors. Now with this one, you surely want to make sure you verify. Well, lots of room for errors, you know. If you come down to this step and it's kind of not working, you know, maybe it's not factorable, but also maybe you made a mistake. You know, lots of different things can be happening. So definitely when you get here, you want to multiply back. Use repeated distribution or FOIL. I'm going to use FOIL here. X times 2x, 2x squared, there's my first term. I'm going to use my outsides. X times -1 is -x. -3 times 2x, my insides is -6x. -x minus 6x, that gives me that -7x. And then -3 times -1 gives me the positive 3. So you definitely want to verify whatever you get left here because there are lots of room for error. If you do hate this method, there are other methods. The box method is actually very similar to this. It's just organized in another way. So pick your favorite method. I actually prefer this one. To me, it's the most straightforward. I can actually see what I'm doing. But, you know, practice all of them. See which one you like best and which one works well for you.